In my last video, I went over how Anthropic is changing their pricing models again. Essentially, it's going to be more expensive to run custom AI solutions with Anthropic because you'll have to now use their standard API costs, essentially, rather than use your $200 a month max plan, and which technically you're not really supposed to be doing if you're an enterprise anyway. They also, by default now, are turning on the data sharing. You can opt out of it, but it's something to be aware of. So if you're an enterprise, it's becoming table stakes to have a hybrid AI strategy. And there's a lot of reasons why you would want to use some kind of a hybrid approach. One reason is durability, meaning like if the service providers go down for whatever reason, which they have, and you've got mission critical workflows that are dependent upon the frontier service providers, you need a backup plan, and so local models can fill that in. Two, cost management. Claude Opus 4.7 is really expensive. All the new frontier models with the high thinking GPT 5.5 is also really expensive. Pinterest recently announced a 90% cost reduction in their AI expenses when they took a hybrid approach. Also, data privacy. When you're running local models, they're running on your infrastructure. The data doesn't leave your infrastructure. It's all self-contained. It's private. So anyway, in this video, I'm going to show you how to quickly and easily get up and running with a local LLM. In production, you probably want to run this on a dedicated machine or server or a container instance running on Azure or AWS or something like that. But for the purposes of this demo, I'm just going to run it on my PC and show you how easy it is to get started. So we're going to use Ollama. Ollama, if you don't know what Ollama is the easiest way to run local open source LLMs. It's basically like Docker for open source local LLMs. So if you go over to the Ollama website, really easy to install it and get started. I am a Windows guy, but I do like to use WSL for a lot of stuff like this. So we're going to go ahead and select the Linux option, and then from a WSL shell, go ahead and just copy this and paste this in and install it. I already have it installed. So yeah, if you don't have it installed, go ahead and install Ollama. And once that's finished installing, just as simple as typing Ollama run and then the name of the model you want to run. And if you haven't downloaded it yet, it'll go ahead and download it for you. Or if you want to download the model and not run it yet, you just run Ollama pull and the name of the model. Some of the larger high reasoning models are pretty large. So for this demo, we're going to go with a smaller model. We're going to use Llama 3.2, which is a model that Meta developed. They've been developing and working on Llama for a long time. Most people are kind of familiar with it, but they have this very small version of Llama. It's a good model. It's small, so it's easy to download quickly, and it runs really fast. And it's really good for text summarization, text classification. They have a 3 billion and 2 billion parameter model, which is relatively small compared to some of these high reasoning models. But if you're doing text summarization and classification, you don't need Opus 4.7. And you can see where Llama 3.2 ranks on the intelligence to cost chart here. So anyway, you can also compare and see some of these open source models like Quinn. Quinn's really popular lately. These are their high reasoning models. 122 billion parameters, 35 billion parameters, but you can see they do have a smaller version of Quinn 3.5, a 2 billion parameter, even like a micro version, and still comparatively perform pretty well. So once it's installed, it's as simple as running Ollama run and then the name of the model. So I've already downloaded a few models. I've got Llama 3.2 and Quinn, but if you needed to download it, you just run Ollama pull and it'll pull the latest version. So I'm going to go ahead and run it, and now it's running and it's just like a chat. So this is a common use case for financial services firms, wealth managers, for any AI generated content that goes out to clients, like market briefings, portfolio briefings, anything like that. It's got to go through a compliance engine. that checks the AI generated content against your compliance policy. In this case, I've got a basic dummy policy set up here. It's got common restricted terms. It requires disclosures. There's tone requirements, and that's all defined in a compliance policy, which, in this project is defined in this compliance policy.txt file. You can see there's a list of restricted terms, and also there's a list or some more detail on what the required disclosures are. And then tone requirements. These tone requirements have to be met in the content. These are 5 example client briefings. Some of these are clean. Some of these have issues. Some of them have minor issues, and some of them are really bad. So let's go through them really quickly. This first one, you can see it's portfolio's equity evaluation. And we guarantee continued strong performance, which is a restricted term. So it should flag that. Recommended increasing your allocation, recommend increasing allocation. That's an unqualified investment advice. That's also a restricted term. It's missing disclosure, so we should expect this one to fail. This one is clean. There's no issues. It should pass. This third one should fail. It's got a lot of issues, a lot of restricted terms, and then also 2 of the disclosures are missing. This fourth one should pass. And then it looks like this final one should also fail. There's several restricted terms, also 2 missing disclosure policies. So we've got a couple of different Python scripts here, very simple Python scripts. There's a local one and a cloud one. We're going to compare the 2. The local one will run against Ollama, and in this case, whatever we're running, the Llama 3.2. It's really simple. It just takes the content from the sample briefings, passes them through your AI provider, in this case, the local LLM, analyzes content against the policy above. It'll take the policy, it'll take the client name and the content, and it'll give it a risk score, pass or fail, list each violation and the remediation. And then I think also it will print the total amount of time it takes, to do the analysis. Same thing for the cloud one, except we're using Anthropic in this case, and it's going to use the Claude Sonnet. Let's change that to Claude Opus 4.6. So these are the sample briefings. It's going to pass the content for each briefing. The expected issues are not going to get passed to the model, but they are basically tests that we can compare our results against and make sure that these expected issues do come up, or the model raises these issues. So let's go ahead and run the cloud version first. And this is going to screen the briefing using Anthropic's API and Claude Opus 4.7. So let's go ahead and do this. See how fast it is. I need to export my Anthropic key first. Okay, now that that's done, let's try again. So it's going to compare each briefing against the compliance policy. So to the first one, great. So this is using Anthropic's Opus 4.7 model and their API. This is making the call to an API running on Anthropic servers. So this one costs, this is their estimate. This is their estimate using 5 cents per million tokens, I think is what we said. I think that's what their pricing is currently for Opus. Let's see, cost pricing is 5 cents per million input, 25 output, 25 cents per million output. So first one should fail. Our score is 92, so that's pretty high. Violations, guarantee language, yes. Unqualified recommender allocation, yes. Missing required disclosure, yes. Missing consult your advisor, that seems wrong, but yes. Actually, let's see what the the detail in the briefing says missing disclosure, no past performance. So I guess it added extras. I guess, better to err on the side of caution, I guess. Remediations, great. Cost, time 13 seconds. But the main thing is we didn't want it to pass, and it didn't. So that's great. Next one should pass. Briefing 2 pass, no issues. Next one should fail. Risk score 98. So this one should have the highest risk score. Let's see, the first one had risk score 92. This one's 98. So that's good. That's what we'd expect. Restricted, slang, tone. This one doesn't expect anything about tone, but okay. So again, it erred on the side of caution. That's not the worst thing in the world, but so screening 4 should also pass. So let's see, yeah, pass. It was clean, or score 10, so that's good. The one that was the cleanest, what did we get the risk score for that one? Yeah, 0. So that's about what we expect. And then the final one should definitely fail. Risk score 92. 3 or 4 restricted terms. Anything disclosures? Yes, disclaimers. And so yeah, so that one was pretty right on. So total time was 49 seconds. So next, let's try running the local version. This one's going to be running entirely on my machine, only local hardware, nothing leaves my machine, no data leaves my machine, no API calls. It's going to call the Llama 3.2 model running via Ollama, and we will compare the results. See, the first one took 21 seconds, second one, 3 seconds. So you see the times, it's actually really fast. So total time is 50 seconds. So it's a little bit slower than the other one, but not by much. Total time 49 seconds. So a little bit faster, but not by much. So let's make sure it scored everything properly. First one should fail. It definitely failed. Violations, guarantee, predict. Yes, unqualified investment advice. Missing past performance disclosure. Did it catch the disclosures? No, it didn't catch the disclosures. So, let's see, what else? Result passed. First one, or this one should definitely pass. It was clean, got a 0 score, so that's good. This one should fail. This was the worst offender here, scored 90, so that's a good thing. Violations, caught all the violations. I'm noticing it's not catching the disclosures. Let's see, remediate. Does it mention anything about disclosures in the remediations? Remove language, replace urgency language. It does not. So it did not catch the disclosures on that one either. So that one passed. That's what we'd expect. And then finally, the final one, risk score 90. Again, though, it missed the disclosures. So even a small local model like Llama 3.2 with 2 billion parameters caught most of the issues. Our Opus 4.7's analysis was more nuanced and caught a few more of the details. But for an initial screening and first pass, the local models are more than good enough. And in a production environment, you're going to want to set up routing anyway. Next time, I'm going to do a demo of a routing tool, an open source routing tool, so you can see how easy it is to set up routing to the various models, some cloud-based, some local, based on rules or thresholds that are met. So tune in next time. Peace.